How do we know anything at all? We take in sense data, like evidence in an investigation. We're investigating whatever this place is, this condition in which we find ourselves. The human brain has evolved over millennia to establish the way we perceive and reason. It's a pretty magnificent machine, the human brain. Streams of data are collected on the skin, the tongue, the eardrum, the retina. These are transferred into action potential signals routed into appropriate thalamocortical networks for processing. It's like a stream of zeros and ones, a raw code of action potentials. We take it for granted that retinal signals produce experiences of blue and green, shape and contrast and motion. We take it for granted that auditory signals produce experiences of music and voices, approaching and receding sounds. It's all so much more remarkable than the credit we give it. We learn so fast. We pick up on the regularities in our perceptions. In no time at all, we can direct the movements of our body, recognize faces and their expressions, find and label objects. Soon we develop a language, syntax, and semantics drawn out of raw auditory perception. From this point on, we can learn directly from the senses that we witness, as well as indirectly through the semantics of the language we comprehend. Every day more and more data taken as evidence of the world we inhabit. We are so smart. We expect an object when removed from sight to still exist in the world. We expect a second or a third trial of the same experiment to produce the same result. Over the course of a lifetime, there is less and less that surprises us. We've accumulated so many instances of so many things, such a preponderance of evidence. As promised in the previous episode, I am returning here to the paper by Hunt, Ericson, and Schooler called Where is My Consciousness-Ometer? How to Test for the Presence and Complexity of Consciousness, 2022. If we can get to a test for the presence of consciousness, we certainly want to do so. Let's see what we can learn from their approach. Recall that they started by outlining the various measurable correlates of consciousness, including the NCC, as well as behavioral and creative correlates. Here's a brief passage to get us back on topic. Quote, "The proposed framework is fundamentally Bayesian in its approach because it depends on each individual's prior judgments about the likelihood of some degree of phenomenal consciousness being present, or not, in the subject at issue. If individuals have significantly different priors, as they surely will, substantively different conclusions may be drawn from the same evidence. However, our approach may over time help to bridge the distance between different perspectives, even if this approach falls short of a definitive test or psychometer. The proposed framework is meant to provide a standardized and general set of tools for examining the universe of potential kinds of conscious entities, and through such examination help to develop a community-based consensus about the presence and type of consciousness in various entities." Unquote. In order to understand what the authors are on about, we need to talk about Bayesian thinking. In his book, From Bacteria to Bach and Back, Daniel Dennett describes Bayes this way, quote, "The Reverend Thomas Bayes, 1701 to 1761, developed a method of calculating probabilities based on one's prior expectations. Each problem is couched thus: given that your expectations based on past experience are such and such, what effect on your future expectations should the following new data have? What adjustments in your probabilities would it be rational for you to make?" Bayesian statistics, then, is a normative discipline, purportedly describing the right way to think about probabilities. So it is a good candidate for a competence model of the brain. It works as an expectation-generating organ, creating new affordances on the fly. Unquote. Rather than being some obscure theorem named after an 18th century mathematician, which of course it is, Bayesian thinking is really something that we are all quite familiar with. The key is that we do not think objectively like a computer, and this is a good thing. Experience has toggled all the levers in our perception and expectations, such that in familiar environments and situations we are rarely surprised. I just set my coffee cup on the desk, for example, and it didn't fall through the surface of the wood. I didn't expect it to do that, and it didn't happen. My implicit assumptions were met, just as they are being met all the time. Imagine being completely objective in your thinking and expectations. You'd be insane. I have a cup of coffee. How do I know it is coffee? Because I made it. I turned on the faucet and filled the kettle with water. Then I poured ground coffee into the French press. When the water was boiling, I decanted it into the press to mix with the coffee, and so on. How do I know that the faucet produced water rather than some other clear liquid? Someone could have tampered with the plumbing or introduced poison. Did I ever take my eyes off the coffee grounds? Could someone have added arsenic or ricin? Is this a French press or some clever facsimile? Have I been drugged? Maybe I'm hallucinating or dreaming. Perhaps as I sit here, the whole memory of making coffee has been confabulated or implanted by some agent. How long have I been sitting at my desk? A few minutes? Maybe that's just what they want me to think. Maybe this so-called coffee is how they keep me in a state of compliance. All right, you get my point, right? Being objective would require that we allow that it's possible that any number of a multitude of alternatives could logically be the case. Bayesian thinking allows us to rely on the past to inform the present so that we know how we should act and what we should believe. Over time, we develop rigid schemas. So if we awake in the night and hear a sound downstairs, we hypothesize that it might be the dog, or even a burglar, but we don't waste time worrying about monsters, or Santa Claus, or alien visitors. Thinking purely objectively would be naive and stupid. In How Not to Be Wrong, Jordan Ellenberg writes, quote, "For those who are willing to adopt the view of probability as degree of belief, Bayes' theorem can be seen not as a mere mathematical equation, but as a form of numerically flavored advice. It gives us a rule which we may choose to follow or not, for how we should update our beliefs about things in the light of new observations. In this new, more general form, it is naturally the subject of much fiercer disputation. There are hardcore Bayesians who think that all our beliefs should be formed by strict Bayesian computations, or at least as strict as our limited cognition can make them. Others think of Bayes' rule as more of a loose qualitative guideline. The Bayesian outlook is already enough to explain why red, black looks random, while red doesn't, even though both are equally improbable. When we see red, it strengthens a theory. The theory that the wheel is rigged to land red, to which we've already assigned some prior probability. What about red, black? You could imagine someone walking around with an unusually open-minded stance concerning roulette wheels, which assigns some modest probability to the theory that the roulette wheel was fitted with a hidden Rube Goldberg apparatus designed to produce the outcome of red, black. Why not? And such a person observing red, black would find this theory very much bolstered. But this is not how real people react to the spins of a roulette wheel coming up red, black. We don't allow ourselves to consider every cockamamie theory that we can logically devise. Our priors are not flat, but spiky. We assign a lot of mental weight to a few theories, while others, like the red, black theory, get assigned a probability almost indistinguishable from zero. How do we choose our favored theories? We tend to like simpler theories better than more complicated ones. Theories that rest on analogies to things we already know about better than theories that posit totally novel phenomena. That may seem like an unfair prejudice, but without some prejudices, we would run the risk of walking around in a constant state of astoundedness." Unquote. We all know that people aren't very good at thinking probabilistically. It seems intuitive that a roulette wheel is more likely to come up red, black than to come up 5 red times in a row, but each of these possibilities is objectively equal. The roulette wheel is not a Bayesian device, but effectively an objective one. If the wheel were a thinking, Bayesian agent trying to be random, it might consider, well, I've put up 3 reds in a row. I guess it's time I switch to black. In fact, experts can easily detect human-made lists of pseudo-random coin flip results relative to real results. The human-made lists look too random, while real coin flips present strings, sometimes long strings of the same result. Dennett writes, quote, "Hierarchical Bayesian predictive coding is a method for generating affordances galore. We expect solid objects to have backs that will come into view as we walk around them. We expect doors to open, stairs to afford climbing, and cups to hold liquid. These and all manner of other anticipations fall out of a network that doesn't sit passively waiting to be informed, but constantly makes probabilistic guesses about what it is about to receive in the way of input from the level below it, based on what it has just received, and then treating feedback about the errors in its guesses as the chief source of new information, as a way to adjust its prior expectations for the next round of guessing. Not least of the attractive properties of these applications of Bayesian thinking to the problem of how brains learn is that they provide a simple and natural explanation of an otherwise perplexing fact of neuroanatomy. In visual pathways, for instance, there are more downward than upward pathways, more outbound than incoming signals. On this view, the brain's strategy is continuously to create forward models or probabilistic anticipations and use the incoming signals to prune them for accuracy, if needed. When the organism is on a roll in deeply familiar territory, the inbound corrections diminish to a trickle, and the brain's guesses, unchallenged, give it a head start on what to do next." Unquote. Dennett points to something important here. The human brain actually operates naturally in Bayesian terms. In fact, I would argue, based upon the same observations Dennett makes about visual pathways and top-down processing, that what we see and hear has already undergone a Bayesian process before we perceive it. Visual illusions make this vividly clear. A cat seen walking in the sun-dappled underbrush beneath an intermittent canopy of cover, sometimes brightly lit, sometimes in shade, usually a spotted mixture of both and always changing, is tracked with ease as the same animal moving gently along in one direction. Getting a computer program to do that is no simple project. We do it automatically. Once we have seen the cat, it is difficult to miss, and if it disappears, we search for it apprehensively, because we know it is still there somewhere. Visual evidence be damned. In science, we form hypotheses in a Bayesian manner. When we want to explain some phenomenon, we devise experiments to distinguish between plausible hypotheses. We don't ever entertain every conceivable hypothesis, and we don't treat all hypotheses in the same way. In other words, we aren't being objective. From where we are situated, there is a tremendous body of scientific knowledge. We understand much of the anatomy and physiology of the nervous system, for example. If a person suffers a head injury and becomes blind, we have a very good idea of where the damage might be. It's kind of like the way we search for things when we're looking for them. If you've lost your keys, it's a good idea to retrace your steps and visit the places where it seems to you that the keys might have ended up. You don't start in one corner of the living room carpet and exhaustively search every square foot, moving the furniture as you go. That would be the objective approach, like a basic computer searching algorithm. 11 hours later, you would discover the keys on the floor next to the bedside table. And you'd be quite late for whatever errand you were on your way to doing. On that note, let's return to our errand, the uncovering of the nature of consciousness. If we know the nature of consciousness, then it's trivial to find cases of it in the world. But not knowing the nature of consciousness, can we find cases of it in the world? Well, I can find me, and I can infer you. I will apply Bayesian reasoning as far as I can justify to assume humans and animals with similar brains are conscious too. We aren't breaking much new ground here. Hunt, Ericson, and Schooler provide a thoughtful review of the neural correlates of consciousness, as well as behavioral correlates and more speculative kinds like creative correlates. All of these are worth considering, and of course, we all do apply Bayesian reasoning when it comes to the way we treat animals and think about other people and the future of artificial intelligence. This way of thinking is worth recognizing, so we can understand how we reason things through, including how we reason about consciousness. There is plenty in this paper that is informative and valuable to me, especially when it comes to the coverage of electromagnetic field theories and the NCC. This episode, though, is not for that purpose. This episode is a contemplation of Bayesian thinking as it applies to the nature of consciousness. It might be the best tool we have, but I fear that the over-application of Bayes to a problem like consciousness is apt to bias us too far in favor of what is familiar in our own time and place. I'll explain how after I give you this summary from the paper. Quote, "The logical chain of the measurable correlates of consciousness framework is straightforward and may be summarized as follows. Starting necessarily from a first-person perspective. I know I'm conscious. I assume other humans are conscious because they act in various ways like me and do many intelligent things. I engage in similar reasonable inferences when assessing whether various animals are conscious and to what degree. We can use the same process as reasonable inference in probing the presence of consciousness all the way down to the chain of physical complexity. In the measurable correlates of consciousness framework more generally, we propose an iterative weight of the evidence approach. The Bayesian approach discussed above, for examining the presence and nature of consciousness in any particular object of study. Under this approach, we would, in any particular case, pose a number of questions in all areas of the measurable correlates of consciousness as described above to the object of study, and it would answer in whatever ways it can. Questions can be verbal in nature, or physical probes, or any kind of interaction between the tester and the object of study. On the basis of whatever responses are received, we then make the same kinds of reasonable inferences about the presence and nature of consciousness that we do every day, implicitly, when it comes to other humans or animals. The question and answer process is meant to be truly general and may apply to any candidate for consciousness, whether it is human, animal, plant, bacterium, AI, or any physical object." Unquote. Okay. The logic is essentially that there are inferences which can give support to further inferences. Given the evidence available from neuroscience, from behavioral and cognitive studies, and from other sources, these inferences are informed by data. The authors say that given data, we can make reasonable inferences, but the word reasonable is pulling too much weight here, in my opinion. Suppose we surveyed 100 neuroscientists on what in their opinion is conscious on a list of ever simpler objects. Human, chimpanzee, panda bear, robot, turkey vulture, alligator, tiger shark, personal computer, sea slug, beetle, sponge, flatworm, oak tree, fern, amoeba, yeast, bacterium, virus, protein, RNA, radio receiver, thermostat, sofa, methane molecule, atom of aluminum, proton, quark. You quantify the informed intuition in the form of a number between 1 and 27, 1 meaning just humans, and 27 meaning everything down to subatomic particles. This might be interesting to do as a piece of social science. We might register the number 5 plus or minus 2, say. This survey might even reveal a consensus. But so what? Back in the day, the consensus was that the Earth is the center of the universe. Diseases like syphilis and smallpox were the work of animal spirits, not pathogens. We aren't historians, we're scientists. We aren't interested in the consensus of human scientists in 2022. We are interested in the truth for all time. The problem with the list I just presented is that it is a descent, more or less, from most complex to least, essentially from the most humanish to the least. As always, a Bayesian prior has been smuggled directly into the survey. That prior might be well-advised or not, but the scientific endeavor is, in its imperfect way, aimed at overcoming bias. I am the only instance of consciousness that I believe in beyond any doubt. I also have 2 arms and 2 eyes, apparently. Should I normalize the list according to eyes and limbs? Now beetle is at the top of the list. Humans drop down. My body is large, composed of countless atoms. Should the list be ordered according to mass? Now the goddamn sofa shows up in the second slot right below the oak tree. Now I realize that this analysis has been unfair. It's not as if Tam Hunt has made such a simplistic argument. And I'm being a bit of a dick. So let me reel it in, because I have a lot of respect for the guy, and his paper is pretty good. The list above can be seen to be ordered more or less in terms of intelligence. Intelligence is a special feature of the human brain, and that is where the known correlates of consciousness are located, the human brain. Undeniably, there are things of which I can be conscious that a lesser mind, say that of a sea slug, if it has one, cannot. Oddly, though, we aren't meant to be searching for the contents of consciousness. We are searching for the vessel.